And if I told you once, I ain't gonna tell you twice. Salute all my real ones. Yeah, look, bro, we got 5 theories about what lies outside the observable universe, more universe. All right, well, that was a great video. We're gonna wrap it up, folks. I'm joking. No, I truly believe that what lies what lies outside the observable universe is more universe, right? Because that's why it's the observable universe and not the entire universe. And I always get the number messed up, but I heard one theory say that the entire universe is 7 times bigger than the observable universe. But then I heard another one that said that the actual universe is thousands of times bigger than the observable universe. And the observable universe is 46 or 96 million, 96 billion light years. Yeah, I'm gonna chop up the numbers. Like, button, subscribe, and notification bell, press those. Let's go. That's why I need to start getting into these videos again. Cause I absorb the information, but then I start like jumbling the numbers up.
About 13.75 billion years ago.
There's a theory that it's actually not 13.75 billion years ago, that the universe is actually only 10 billion years old.
Our universe as we know it today was created. Shortly thereafter, the primordial light began to shoot through the cosmos and spread throughout the entire early universe. At this time, the universe itself also expanded. However, the inflation of the universe slowed down after the first initial eruption. But since then, the rate of expansion has been steadily increasing due to the influence of increasing dark energy. In essence, the cosmos has been growing at an ever-increasing rate since its creation. Physicists and mathematicians have been studying the nature of the universe for hundreds of years, trying to solve the mysteries it contains. But there are some scientists who go one step further into the unknown by thinking about what lies beyond the boundaries of our universe. Is it possible that there is something else beyond the existence of our own universe?
Wait. Beyond the existence of our universe or our observable universe? Because I feel like those are 2 different questions. What lies beyond the observable universe is different from what lies outside of the universe, right? Like, those are 2 different questions. I tend to always be more enthralled. I don't want to use that word. I mean, that is the word, but I tend to be more intrigued, and my mind always tends to try to visualize or try to theorize what's outside of our universe, right? And then like I'll go into the question of, all right, cool. If there's something outside of the universe, is it possible to exit the universe, right? Whether that's through a wormhole or you're speeding off, you know. Obviously, you would have to go faster than the speed of light, but you would also have to go faster than the speed of the expansion of the universe. But then, in which direction would you go? And then, if you tie that back into the theory that it doesn't matter where you are in the universe, if you move. We're here on Earth, and we look out, you know, our observable universe stays constant. If you move to a different point, let's say 1 billion light years away, then even though you move, the observable universe for you would be different, but would be the same size. So then the question becomes, can you actually even escape this universe? Right.
Other universes, worlds whose existences we can only guess at.
And then if there's another universe, right, outside of because a lot of people, well, not a lot of people, but there are certain scientists that believe that there are universes that exist parallel to ours or right next to ours? Is there a way to build a bridge or exit this universe and go into another one? And how would you do it? Or also, there's also a theory that, that just because there's a universe next to ours, the laws of physics to that universe might be different. And just because we could travel to that one doesn't mean that we'd be able to survive. So, right, it could be a thing where, you could go into an antimatter universe, right? So if we went to an antimatter universe and we touched anything there, annihilation. But also it could be, things where electrons and positrons and neutrons, they're all charged differently. And once we enter that universe, like, we dissipate. Yeah. I don't know if I did the best job of explaining it, but yeah, I get the gist.
That could well be the case. Here are 5 theories about what this something could be, and what clues there are for the various theories. If you like our videos, please suppose that will be waiting for you. Hubble volume. The notion of outside the universe is very tricky, because first the universe has to be defined more precisely. A common form.
Right, and also you would have to say that the universe has a limit, as the universe is finite in order to be able to go beyond the end point of the universe. Right.
Formulation, which does more justice to the core of the matter, is the term the observable universe, whereby the speed of light plays a major role here. Since we can only see things when the light that they emit or reflect reaches us, we can never see further than the greatest distance that light can travel in the time that the universe has existed. Cosmologists estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light years since the Big Bang.
Right. So that's what I was going to say. That's why I was saying earlier, is it 46 or 92? I was basically multiplying by 2. So the observable universe for us is 46 billion light years across, right? And then scientists theorize that the universe could be either 7 times or thousands of times bigger than that. And it doesn't matter where you move, whether you move, so right where, 46 billion light years across, if you move 23 billion light years away, you still see 46 billion light years across, but, the stars would be different. But then the question becomes, if you keep moving and then you still haven't exited this universe, then there's nothing beyond it.
This means that
not that there's nothing beyond it, but you can't escape the universe.
The observable universe is about 93 billion light years large, plus or minus a few light years. These approximately 93 billion light years contain all the quarks, quasars, stars, planets, nebulae, black holes ever recorded by a telescope, and everything else that we might be able to observe but have not yet seen. But the observable universe contains only the light that has had time to reach us. This also means that
And also, there's also the problem that speed of light, 186,000 miles per second, the universe is expanding faster than that. So if a photon is if this is the Earth, and a photon is trying to come to us, but the universe is expanding faster, then technically it doesn't matter how, that photon can travel for as long as it wants. It's technically going away from us because the space that's in between us is expanding faster than the photon is able to travel towards us.
The observable universe is getting bigger and bigger. However, the universe is also finite. The limited amount is also called the Hubble volume, after the telescope that has given us the most distant views of the universe so far. We will never be able to see beyond this limit, so it's basically the only universe with which we can ever interact. However, we know with a probability bordering on certainty that there is more universe beyond that limit.
That's what I was saying.
Astronomers believe that space, invisible to us, could also be infinite, with matter, energy, galaxies, etc., distributed pretty much exactly as in the observable universe. Beyond the Hubble volume, we will not only find more planets, but also other planets very similar to our Earth. If we go far enough, we will find another solar system with an Earth that is identical in every respect. Where you had cereal for breakfast this morning instead of eggs. And another world where you skipped breakfast. And yet another world in which
I think he's conflating the two. I mean, technically, right? If the universe is that large, it's possible that, you know, another version of you exists. But, you know, I don't know how true that is. I think that theory is better explained in when you start up talking about a multi-dimensional universe. But like another me or another you existing within the same universe, like nah, because I'm gonna find that other me and I'm gonna smack him up and tell him you gotta go, bro. You know what I'm saying? There's only one of us that can exist in this universe, and it's gonna be me, bro.
which you got up in the
And I'll challenge him to a duel. I'll go like that. Pop, pop. I challenge you to a duel. Take 10 steps and draw a champ. Except that on 9, I'm a, you know what I'm saying? I'm not going, because like I know my skills, and if it's like an exact copy of me, then I know he got skills. So I'm gonna have to take a step at instead of taking 10 steps, I'm gonna draw at 9. But knowing him, he's gonna want to do the same thing. So I'm gonna have to draw at 8. But then because he knows that I know that he knows that I know what he's doing, he's gonna do it at 8. So basically, I'm just gonna have to go pap pap and then pull out and send him on his merry way right there.
in the morning and then robbed a bank. In fact, cosmologists believe that if you go far enough beyond the boundaries of the universe, you will find another Hubble volume that is completely identical to ours. And in those other Hubble volumes, there is another version of you out there that reflects every possible action you might take. This may seem unlikely, but then again, the infinity of the universe is very hard to imagine because it's simply beyond human imagination. To break this down, according to the theory of relativity, objects that are close together cannot move against each other faster than the speed of light. However, there is no such law for objects that are extremely far apart when the space between them expands. In short, it's not that objects move faster than the speed of light, but that the space between the objects expands, causing them to fly away from each other at amazing speeds.
Right.
Ultimately, this means that we could only reach the edge of the observable universe if we developed a transport method that would allow us to either 1. Travel faster than the speed of light, a theory that most physicists believe to be impossible, or 2. Transcend space-time by wormholes or warp propulsion, which most physicists also believe.
I'm pretty sure there's a brown-skinned guy that said all of this earlier before, but you know what I'm saying? It's just logical.
To be impossible. Dark flow. In 2008, astronomers...
Yeah, I had like, I don't know what I was thinking, but my friends was like, yo, you want a White Castle burger? I'm like, yo, don't nobody want no White Castle. And then like, cause there was nothing else and I didn't want to order. I think it was like at the Super Bowl or something. And then I wound up eating it. Then I came home, you know what I'm saying? I don't know about all this universe stuff, but you know what I'm saying? There was a lot of dark flow that night. Slap sneak. Corny joke time. Let's go.
Discovered something very strange that they had not expected. Galactic clusters were streaming in the same direction at immense speeds, over 2 million miles per hour. New observations in 2010 confirmed this phenomenon known as dark flow. Scientists discovered the phenomenon.
Sometimes I'm too immature. Like this guy's gonna need to stop saying dark flow.
By studying some of the largest structures in the cosmos. Giant galaxy clusters. These clusters are collections of about 1,000 galaxies and very hot gas that emits X-rays. By observing the interaction of X-rays with cosmic microwave radiation, or CMB, left over from the Big Bang, scientists can study the motion of clusters of galaxies. The X-rays scatter photons into the CMB and shift the temperature in an effect known as the Sunyaev-Zeldovich kinetic effect. This effect had not been previously observed as a consequence of clusters of galaxies, but was first noticed by a research team led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center, when it examined about 700 clusters that were up to 6 billion light-years away, halfway across the universe. They compared these clusters with the map of the CMB taken by NASA's Wilkinson Microwave Anisotropy Probe (WMAP) satellite. The motion of the clusters defies all predictions about the distribution of mass in the universe after the Big Bang. One possible cause: massive structures outside the Hubble volume that exert a gravitational influence. Scientists are almost certain that the source of the suction lies outside our known universe. This would mean that the structure of the infinite universe is not uniform beyond our point of view. As for the structures themselves, they could literally be anything, from accumulations of matter and energy on almost unimaginable scales to bizarre fault lines that conduct gravitational forces from other universes. Infinity bubbles. Talking about things outside the Hubble volume may be misleading
Infinity bubbles.
because it is still the same universe. Only part of it we cannot see.
I'm gonna get these bubbles and go.
The same physical laws and constants apply. In another version of the story, the expansion of the universe after the Big Bang led to the formation of bubbles in the structure of space. Each bubble stopped expanding together with the rest of space and formed its own universe with its own laws and physical constants.
Right.
In this scenario, space is infinite, and each bubble for itself is also infinite, because a single infinity can contain an infinite number of infinities. Even if you could somehow break through the boundary of one bubble, the space between the bubbles would still expand, so you would never reach the next bubble, no matter how fast you move. Black holes.
That's some BS right there, bro. That's some. I'm not that the theory is BS, but like if that's really the case, it's like damn, like there's so much universe out there that basically we're being told like we'll never be able to reach. Like I would hate the thought of that, because like part of me is like, man, like if our technology was advanced enough, I would want to be able to visit those different far out places in the universe. It's funny because one of my relatives was asking me like, oh, Elon's trying to go to Mars, like would you go to Mars? Hell no. Have y'all seen how astronauts have to survive in space? Like you're drinking purified urine and no way, like come talk to me when space travel has gotten to the point that it's just like Star Trek The Next Generation, where they got replicators and gravity, and you know what I'm saying? Like when they got all of that, come talk to, and holodecks, all that stuff. But the way that they got it now, I'm good. Like no way. You know what I'm saying? I basically gotta eat microwave dinners, blood pressure through the roof and radiate. No way. I'm good.
A theory proposed by physicist Lee Smolin, known as the theory of fertile universes, states that every black hole in our universe causes the creation of a new universe.
I said, I don't know what video that is. One of y'all could find it, but I said that there's a theory that, so he's saying that whenever a black hole is created, a universe is created. There are people that believe that not only is a universe created when a black hole is created, but that you could actually travel through that black hole to get to that other universe, which you let Neil deGrasse Tyson explain it, it's not happening, because when you get anywhere near close to that goddamn black hole, you're gonna get spaghettified. That's what he says. You're gonna get spaghettified. I'm more of a lo mein type of guy, but I get it.
Universe will have slightly
I want to order some lo mein right now.
different physical laws than the previous one. In this way, Smolin suggests a kind of natural selection for universes. Since laws and physical conditions that lead to the frequent formation of black holes are also the reason for the formation of other universes, while universes that do not form black holes become extinct. The theory has since been disproved by Smolin himself and others.
Right.
Infinitely many parallel universes.
Right.
There are innumerable theories about parallel universes, but the most valid theory today involves a further development of the ideas of the string theory. This involves so-called membranes that oscillate in other directions. It would go beyond the scope of this video to go into too much detail about string or membrane theory, but the core of the theory is that the rippling membranes beyond the worlds in the 11th dimension are completely different universes, and when the ripples collide, a new universe is formed. The effects of the wave motion help to explain the observed distribution of matter in our universe. One of the strangest elements of the theory is the notion that all the gravity we experience in our universe actually enters this universe from another universe in another dimension, which explains why gravity here appears so weak compared to the other fundamental forces. What do you think? Do other unknown...
But yeah, I mean, those are all pretty cool. I think I get most disappointed by the one talking about that if you left this bubble, which is this universe, and tried to reach another one, then because it doesn't matter how fast you go, you're never going to be able to get to the other one. That would be disappointing to say the least. But we're going to leave it there because this video is long enough. Let me know what y'all thought of the video. My name is Rain. Catch you on the flip side. RCP salute. Wait for it. Dab on them.